So just sort of an expression, not an equal sign. We're switching gears a little bit, and we're going to now work with rational equations. So we're putting an equal sign, and all we're doing is working at solving them. So we're going to learn how to solve rational equations. So we still need to be able to determine the non-permissible values for the variable in the rational equation. We need to determine algebraically the solution to a rational equation. And we need to explain why a value obtained in solving a rational equation may not actually be the solution. So a rational equation is an equation where at least one of the terms is a rational expression, which means it's a variable with a denominator. So it might be something like x over x plus 1 equals 4. Or it could be more complicated. We could have x over 6 plus 1 over x plus 1 equals 3 plus x over x squared. Those are rational equations. It has to be an equation, so there has to be an equal sign, and there has to be a variable in the denominator of part of the fraction. And then a couple things we have to do is we always have to verify our solution. So once we solve it, we have to take our solution and plug it back into the original equation to check it, which then means you always know if your answer is right or wrong if you actually check it. And if you get a solution that equals a non-permissible value, you have to reject that solution. Right? So if, like in this case here, you can't have x equal to -1. So if you solve this and your answer was x equals -1, then that means it has no solution. So we're going to look at two ways of solving. Cross multiplication, which is the easy one, okay? And then looking at having to add or subtract, like giving a common denominator. Okay? So the more you can take an equation and get it to the point where you can solve by cross multiplication, the easier the questions are going to be. So to solve an equation using by cross multiplication, you have to have so that you just have a single term on each side of the equal sign, so something like this. Because basically what you're doing is cross multiplying and dividing. Okay, is kind of the way of thinking about that. So for cross multiplication, you need one term on each side. And so then what you're going to do, the first thing you have to do is state your non-permissible value. Always the first thing you do, or like factor if you can. Solve the equation algebraically, then you're going to verify the solution by taking your number and plugging it back in, and then you're going to, we can also verify it using our calculator. So all of these can be solved graphically, and that's okay for multiple choice numerical response questions, but if you have an algebraic, or if you have a written response and it says solve algebraically, you have to do it algebraically. And I'm going to show you how to do it all graphically. So cross multiplication literally just means that, like you're going to cross multiply. So we're going to go 3 times 1, or just 3, and that's equal to 6 times x plus 3. Here, what did I forget to do? Anybody? Non-permissible value. What you're trying to do with cross multiplication is get it down to being like a linear equation, or getting it down to being like getting rid of the denominators. That's the whole point of cross multiplication, getting rid of the denominators. Because look at that, I have 3 over x plus 3 equals 6. Now I've got 3 equals 6 times x plus 3. Then this just becomes 3 equals 6x plus 18. Right? It's 6 times x, 6 times 3. So then I'm going to subtract 18 from both sides. So that gives me 15. So negative 15 equals 6x. And my last step whenever I'm solving algebraically is always to divide. So at this point I'm going to go divide by 6, divide by 6. So I get x is equal to negative 2.5. Or I can leave it as key number 6, 5 over 2, or leave it as negative 2.5. Now, I want to verify this algebraically. So what I mean when we want to verify something algebraically, what that means is we want to look at the left side and the right side separately. And we want to make sure the left side equals the right side. So if I've got, my left side is 3 over x plus 3. Okay, so I can't do anything on my right side, but I want to make sure that if I plug in the value I got for x, this should equal 6. Because that's what the equation said, 3 over x plus 3 equals 6. So 3 over negative 2.5 plus 3, that equals 3 over negative 2.5 plus 3 is 0.5. And 3 divided by 0.5 equals 6. So that means this is my solution. Now, you won't necessarily, on a quiz or a test, get a mark for verifying, but why wouldn't you? Right? Because that means you know for sure you got the answer right. If it works, your answer's right. Okay. But you can also verify on a calculator. Now, I'm a little worried this is going to crap out the video, but let's see what happens. If I can actually, because I've tried to do other stuff on the video and it's had issues. I'm going to leave the using a calculator to the end, just because I don't want to wreck the video and have to start over again. So we'll do everything, and then we'll go back in. I'll pause it, and I'll see if it works, and then, yeah, we'll do that. So the people who aren't here are just going to have to get in the calculator step. Okay. So... okay, so the second one here. 3 over x plus 3 equals 9 over 4x plus 7. So our second term's gotten a little bit more complicated. We want to do our non-permissible values first. So we have x plus 3 equals 0. So x cannot equal negative 3. And 4x plus 7 equals 0. So 4x equals negative 7, which means x cannot equal negative 7. And I'm just going to cross multiply. So 3 times 4x plus 7 equals 9 times x plus 3. And then 3 times 4x is 12x. 3 times 7 is 21. 9 times x is 9x, and 9 times 3 is 27. So when I get down to an expression like this, where I have an expression with a variable and a constant on each side of the equal sign, I need to get all my variables onto one side and all my constants onto the other. So, and I like to keep my variable number positive if I can, so I'm going to subtract 9x from both sides, which gives me 3x plus 21 equals 27. Then I'm going to minus 21 from both sides. So I get 3x equals 6. Divide by 3. X equals 2. And so one of the first things I do is I check, is that one of my non-permissible values? No, it's not. So then what I want to do is verify. Okay, so left side was 3 over x plus 3, and it was 9 over 4x plus 6. Okay, so we have to plug that 2 into both of them. And what we want to do is make sure that this side equals that side. So if I put 2 in here, I get 3 over 2 plus 3, which is 3 over 5, and I can just leave it like that, or I can write that as 0.6. And then on this side, I want to do 9 over 4 times 2 plus 7, which is 9 over 8 plus 7, 9 over 15, or 3 over 5. Whether you choose to do that and keep it as a fraction or turn it into a decimal, it's totally up to you. Any questions so far? Okay, so the question on the next page, it's similar, except it starts with where we've got 2 terms on the left-hand side and 0 on the right-hand side. So when we get that, we can rewrite it so we get a single term on each side. So we would just rewrite that as 2x over x plus 2 equals 5 over x plus 3. Because that's subtracted, so I'm just going to add that 5 over x plus 3 to both sides. So that cancels it here. And then I'm in a situation where it's a little easier to cross multiply and divide. Oh, yes, thank you. X plus 2 equals 0, so x cannot equal negative 2. And x plus 3 equals 0, so x cannot equal negative 2. Okay, so cross multiplying here. 2x times x plus 3 equals 5 times x plus 2. Okay? 2x times x is 2x squared. 2x times 3 is 6x. And that equals 5x plus 10. Okay. When you end up with a linear equation to solve, which was what was on the previous page, these are both linear. Because all you have, your biggest exponent on your x was 1. Right? We had negative 15 equals 6x, so that's x to the power 1. Then over here we had 12x plus 21 equals 9x plus 27. That's linear. When you're doing linear, you want it, like you just solve it normally with algebra, the way you would normally solve it. The one that we just did, we have an x squared term. So when we have an x squared term, we have a degree 2 variable. We need to get all of everything onto one side and have it equal 0, and then we're going to factor to solve. Right? We're going to factor trinomial. So this is going to become 2x squared, but 6x minus 5x, that gives me x, and then minus 10. I also want to point out to you, because I missed this, determine the roots of the equation by cross multiplication. When we're roots is the same as solutions, is the same as zeros. They all mean the same thing. So the root of an equation is the solution is the solution, the zeros are the solution. They all mean the same thing. Okay, now we are in a situation where we have to factor trinomial, the coefficient, on the x. So there's different ways of doing this. Okay? I have my way that I like doing it, which is not the tree method. The tree method, or whatever it is the way that you've done it. And however you would normally, if you learned to factor this in previous math courses, factor it that way. I'm going to show you the way that I factor it, which some people like, some people don't. Okay? So it's totally up to you which way you want to use it, or what you want to use. So over here, I'm going to factor. Okay, so I've got 2x squared plus x plus 10 equals 0. Now normally if I don't have a coefficient on the x squared, then I want two numbers that multiply to the constant term and add to the coefficient on the middle term. I want the same thing here, but I want, oh, thank you. Okay. I want two numbers that multiply to 20 and add, to negative 20 and add to positive 1. So, whenever you want to, when you're factoring, no matter what, if you're trying to add to positive or negative 1, you need, your numbers that you're working with differ by 1. So in the case of 20, we want two numbers that will multiply together, give us 20, but when we add them, there's just a difference of 1 between them. So that's going to be my number. I want to multiply to negative 20. So one's got to be negative, one's got to be positive. So, and I want to add positive 1. So negative 4 and positive 5. Right? Because negative 4 plus positive 5 gives me positive 1, and negative 4 plus positive 5 gives me negative 1. The way I factor here now is what I do is I take these two numbers and I rewrite this term as the sum of those two numbers. So I get 2x squared minus 4x plus 5x minus 10 equals 0. I haven't changed anything, right? Because negative 4x plus 5x gives me positive x. I'm just rewriting that number differently. Then I want to take out common factors. So if I look at this, I can take out 2x and I'm left with x minus 2 plus 5 times x minus 2. And now I've got my two factors, x minus 2 and 2x plus 5, which you would still get using the tree method. But it's easy to mess up your numbers using the tree method. This way works every single time if you understand it. Okay, like I said, factor the way you want to, and the number of times you have to factor a trinomial with a coefficient on the x squared is very minimal. Like, chances are you're not going to get it on the diploma exam. It will show up in assignments and quizzes and tests. It may be on the diploma exam, but I can show you ways around that. The diploma exam is also supposed to remember response. So I don't want you to panic if this doesn't make sense. But remember, like, that's a skill from previous math courses that you should have coming in here. So if you're having trouble with this, I can give you questions to practice, but I'm not going to spend any more time working on that. So what I end up with here now is that x minus 2 equals 0. So x equals 2. That's one solution. And 2x plus 5 equals 0. So x is equal to negative 5 over 2, or negative 2.5 is the solution. Any questions about that? Like anything that's just niggling at you right now, that's quick, other than just, I don't understand the factoring. Because, like, I mean, I can't go over that in class now. Like, you can't come talk to me if you want to do that. I want to kind of know if there's anything in there that's sort of trouble. This is a good one to actually, I'm going to stop the video and we're going to use a calculator to verify this. I'm going to show you how to do that. So I'm just going to pause this. We're going to move on and look at slightly, like, just a different way of doing it. Some of you may find this one easier, some of you may find it harder. Okay? Where I see a lot of you guys doing stuff is the algebra. It's not the actual dealing with irrational expressions. It's like solving algebraic equations, and like that's in there. But remember, on the diploma exam, you can use your calculator. It's only on my exam you have to be able to show your work, right? So like there are ways of doing this with the calculator that make it quite easy. Okay. Oh, actually, sorry, I lied. We're gonna look at. Yeah. Okay, so these are kind of common questions to get on the diploma exams, where they kind of give you somebody's solution and you have to figure out at what line they went wrong. Okay, where they went wrong. So we have Leo trying to solve the equation 1 divided by x minus 1 equals 4 divided by x squared minus x. Okay, and he's got his work shown below, and we just want to check to see like if we can figure out where it is he went wrong or what happened. So it's up to you how you approach this. Like sometimes the easiest approach is just to actually start with what it's trying to solve and solve it yourself to see what if you can tell where the mistake is. So if we just start over here on the side, kind of solving for this stage is right, because that's just cross multiplying. I've got 1 times x squared minus x equals 4 times x minus 1. Okay, so that line was okay. Then if I expand this out, that's what Leo's got there too, so that's okay. I have a squared term, which means I want to get everything onto one side, okay, and have 0 on the other. So I've got x squared, I've got negative x minus 4x, so negative 5x, and then I'm going to add 4 to both sides. So I have a trinomial to factor, but it's an easier one, right? I want two numbers that multiply to positive 4 and add to negative 5. Any contributions? What two numbers multiply to positive 4 and add to negative 5? going to be 1 and the last number. Always. Get back there. Okay. So that means x equals 1 and x equals 4. Which is what he got. Okay? So it's not in this work where he went wrong. Now, the one thing I didn't do here was my non-permissible value. X minus 1 equals 0, so x cannot equal 1. X squared minus x equals 0, so that gives me x times x minus 1 equals 0, so x cannot equal 0, and x cannot equal 1. So what Leo did wrong was his solution of x equals 1 must be rejected, as x equals 1 is a non-permissible value. Now we're going to look at the second method, the second way of doing this. And this is more for when you end up with a rational equation that has more than one term on each side of the equal sign. So what we do when we're going to solve by multiplying by the lowest common denominator, what you do is multiply every single term by every single denominator. So I look at this here. My lowest common denominator, my denominator is x. Okay? So I'm going to multiply this by x, this by x, this by x, and this by x. So what I get is 4x plus 2x over x equals 6x plus 3x over x. The point of that is to eliminate denominators. If I multiply every single expression by the same thing, I haven't changed my equation at all. But now I have a place where I can cancel these x's out. The equation I have left to solve is 4x plus 2 equals 6x plus 3. And now I'm back to that kind of one being able to just get all my x's on one side and get all my constants on the other side. So I'm going to minus 4x from both sides. That gives me enough. I don't care, like you don't have to show me the algebra. I'm showing you the algebra so that hopefully you can understand what's going on. Then I'm going to minus 3 from both sides. Oh, and I forgot to do something. So negative 1 equals 2x. So x is equal to negative 1 over 2. My non-permissible values here, x cannot equal 0. I can verify here as well. I want the left side to equal the right side. My left side was 4 plus 2 over x. My right side is 6 plus 3 over x. So 4 plus 2 over, was it negative 0.5 is 4 plus negative 4, which is 0. 6 plus 3 over negative 0.5 is 6 plus negative 6, which is 0. Left side equals the right side, so my answer is right. Any questions? because I want to kind of use it to illustrate really what's going on here. So at this point here, okay, you're multiplying every term by every denominator. So our denominator here is x minus 1. So I'm going to times this by x minus 1, I'm going to times this by x minus 1, and I'm going to times this by x minus 1. Every term by every single denominator. So that, what the point of that is to eliminate the denominators. Okay, so that just means that eliminates itself. So then I have x times x minus 1 plus 2 equals 4 times x minus 1. Oh, and non-permissible values. X minus 1 equals 0, so x cannot equal 1. And so from here now I need to just use my distributive property. So x times x is x squared. X times negative 1 is negative x plus 2 equals 4x minus 4. And I've got a squared term, which means I'm going to have to factor to solve. So I'm going to move all of this stuff over here. So get x squared minus 5x plus 6 equals 0. What are my two numbers that will multiply to positive 6 and add to negative 5? Yeah, okay, x minus 2, x minus 3. Right, negative 2 times negative 3 is positive 6, negative 2 plus negative 3 is negative 5. So that means x minus 2 equals 0, so x equals 2, and x minus 3 equals 0, so x equals 3. The numbers that you get when you're factoring this are not your answers, they're your factors. Yeah. Negative x minus 4x is negative 5x. But my x is the 1. You see, yeah, like it's this times this times this, and then plus 2. Yeah. You okay? You okay with that, Sarah? Yeah. Yeah. So these are my two solutions, which I can verify if I want. Okay. So your factors are not your solutions. Like your factors, you have to set equal to 0 and then solve for your solutions. Okay, so I'm going to verify, and I've got 2 to verify. I've got x equals 2 to verify, and x equals 3. So my left side and my right side, and my right side was equal to 4, so that's what I'm trying to get to. My left side, I've got 2 plus 2 over 2 minus 1, so that's 2 plus 2 over 1, which is 4, if that one works. And then I've got, it's 3 plus 2 over 3 minus 1 is 3 plus 2 over 2, which is 3 plus 1, which is 4, which is what I wanted to write. Guys, the verifying isn't like you're not, there's no mark involved in verifying. It's more for your own sort of peace of mind to know that you've got the question right. We're going to do a couple that are a little bit more complicated. Okay. Multiply every term by every denominator. Every term by every denominator. We have 2 different denominators here now. So we have to multiply every term by both denominators. So this we're going to multiply by x plus 1 times x minus 1. This one we're going to multiply by x plus 1 times x minus 1. And this one we're going to multiply by x plus 1 times x minus 1. What that allows me to do is cancel out the common denominator So the first time I cancel the x plus 1 over x plus 1, and I'm left with 3 times x minus 1. This one I cancel out my x minus 1, and I'm left with 1 times x plus 1. This one I can't cancel anything, and I have 2 times x plus 1 times x minus 1. Oh, and non-permissible values, x plus 1 equals 0, x cannot equal negative 1, x minus 1 equals 0, x cannot equal 1. And then I've got a bit of expanding to do here. 3 times x minus 3 times 1 plus 1 times x plus 1 times 1. This one over here, I'm going to FOIL this first. Okay? X times x is x squared. X times negative 1 is negative x. 1 times x is x, and 1 times negative 1 is negative 1. X plus x is 4x. Negative 3 plus 1 is negative 2. And then over here, I get 2 times x squared minus 1, because these cancel. So 4x minus 2 equals 2x squared minus 2. Now I've got an x squared term. You guys, if you're not going to that. Okay. I left the video recording over. You can have it if you want to practice. I don't know. It's up to you. If you don't have to. No, because it's just like it replaces, like if you do better on the test, it replaces your own. And yeah, and you're like, I don't have any issues with you. So I'm like, if you want to practice, take it. But otherwise, just remember test tomorrow. Test tomorrow. Yep. Okay. Okay, I've got a squared term, so I want to get everything on one side. So I'm going to minus 4x to both sides, 2x squared minus 4x, and I need to add 2 to both sides, which just gives me 0. Okay. So I'm left with 0 equals 2x squared minus 4x. Now, as binomials go, or degree 2 polynomials go, this is a nice easy one to solve, because I'm just going to factor it. I've got 0 is equal to 2x times x minus 2. Right, so I'm just factoring this. And what that then means is 2x equals 0. So x equals 0 is one solution. And x minus 2 equals 0. So x equals 2 is a solution. In the effort of just kind of moving on to do some more questions, I'm not going to bother verifying this one, but I could. But you can also verify it quickly on a calculator. Okay, this one looks scary, but it's not. Okay, I need more space, so I'm just going to spread this out. This one actually, it looks, like what I meant by it looks scary, but it's not, is it's actually a lot less work to solve than the one up there. Okay. denominator here. Because I can factor that, right? Like I can simplify that a little bit by pulling out an x, and I can write that as x times x minus 4. So when I say multiply every term by every denominator, every term by the lowest common denominator, I'm just multiplying every term by this. So times x minus 4 times x minus 4 times x minus 4. So the whole denominator, x minus 4 cancels, and that just becomes 16. For this one, the x minus 4 is canceled, and I'm left with 4x. And for this one, the x is canceled, and I'm left with negative x minus 4. So 16 equals 4x minus x plus 4, or 16 equals 3x plus 4. What happened here? Oh, I'm sorry. Thinking something wasn't right. I'm going to minus 4 from both sides, so I get 12 is equal to 3x. So then x is equal to 4. But, did anybody do an optimistic values when I didn't do that? Okay. X equals 0, or x cannot equal 0, and x minus 4 cannot equal 0, so x cannot equal 4. Okay. I have to reject that solution. No solution. Yep. So reject. Therefore, no solution. Okay. So on the next page, if you're ready, the other one just kind of looking at. Okay. Caitlin and Taylor were solving the rational equation 4x minus 2 divided by 2x plus 3 equals 6x minus 1 over 3x plus 5. Caitlin used the method of the least common denominator, which is the one we just did, where you're multiplying every term by every denominator. Taylor used a method of cross multiplication, and their work has been started below. So this is where, like, we would multiply every term by every every denominator. So we're going to multiply this term by both 2x plus 3 and 3x plus 5, which allows us to cancel the 2x plus 3s, and we're just left with 3x plus 5 times 4x minus 2. Same thing on this side, but we can cancel the 3x plus 5, and we're left with that expression, which is exactly the same thing as you get if you just cross multiply. Okay. So both methods get you to the same spot. So if you don't like cross multiplication, use the lowest common denominator one. If you don't like lowest common denominator, find a way to use cross multiplication. So they arrive at the same step. So both methods work, is the other way of saying that. So we're just going to try this one, because initially this looks a little bit hairy because of all the binomials that we have to FOIL. But it's not as bad as you think it's going to be. Okay. So I'm going to FOIL. So first, outer, inner, last. So 3x times 4x is 12x squared. 3x times negative 2 is negative 6. 6x. 5 times 4x is 20x. 5 times negative 2 is negative 10. 2x times 6x is 12x squared. See, and that's where I said it's going to be kind of easier than it looks because those are going to cancel. 2x times negative 1 is negative 2x. 3 times 6x is positive 18x. And 3 times negative 1 is 2. So I'm just going to combine my middle terms. 12x squared plus 14x minus 10 equals 12x squared plus 16x minus 3. So what would happen there is I go negative, I minus 12x from both sides, which means that basically those two terms are the exact same and they exist on both sides of equal signs, so I can cancel. So I'm left with 14x minus 10 equals 16x minus 3. So I'm going to subtract 14x from both sides to give me negative 10 equals 2x minus 3. Then I'm going to add 3 to both sides. And I get negative 7 equals 2x. So x is negative 7 over 2. Okay, guys, I'm going to stop it there. There's the 3 your turn questions on the next page. You can try if you want. I'm also going to give you text pages. So I'm going to write the answers on the board for those 3 your turn questions if you want to try them so that you know like if you're getting to the right spot or not. You guys all done writing that down? Okay, so A should be x equals 1. B should be no solution. And C should be x equals negative 8.5. And then your assignment. In your text, page 258, numbers 1 and 4 to 6. Not a lot, but you know, like if you're feeling pretty comfortable with this, you probably don't need to practice a lot. But if you're not feeling confident, you want to practice. Like you've got to get the algebra down, and